Hi everyone, welcome back. In this video we'll see the priority scheduling algorithm with preemptive mode. Guys, generally priority scheduling algorithm means it is going to have one extra parameter called priority and the processes are scheduled based on the given priority of the processes. Okay, so the priority can be classified like whether a low priority or a high priority. In general, they will clearly mention L means here low priority, H means high priority. I mean, when a process having higher number, which means it's having higher priority. When a process having lower priority number, it's going to have lower priority, right? There might be about case that we have seen in the earlier videos, right? So without wasting any delay, we'll go with the Gantt chart. Guys, Gantt chart is a simplified process in order to define how the processor are executing. And one more important criteria here, the criteria what we are following is priority, and that will be also to preemptive processes. Means there might be a chance you might get higher priority, then you have to preempt yourself and you have to give chance to the other process. Okay, so assume that this is a CPU and 0 units of time. At 0 units of time, what are the processor arrived for us? P1 arrived at 0 units of time, and whose burst time is given for 5 units. But as we are having only one process P1, no need to check with the priority. Right? As it completes 1 unit of time, that means it is left with 4 units. How many processes are there for us? 2 processes are there for us, because one is 0 arrival time process, another one is 1 arrival time process. By the 1 unit completion, we are left with P1 and P2. Which one will get the highest precedence, higher preference? That is based on what scheduling algorithm we are following. We are following here priority schedule algorithm, which means higher number having higher priority. Which means out of these two processes, which have higher priority? Process P2. So process P2 will be scheduled first and will be allocated for 1 unit of time, will done by 2 units, which means as it is done with 1 unit, it is left with 3 units, right? By the time of 2 units, one more process added into the ready state, right? Which means this is. Now when you look into this particular thing, by the 2 units completion, the process which are having the priority are 8, 9 and 10. Which having the highest priority? Definitely P3 having the highest priority, because it is larger number, because higher number having higher priority. So now it will get it for 1 unit of time, will done by 3. At 3 intervals of time, any process is there? No, only P1, P2, P3 are there. So out of these 3, which one having the highest precedence again? P3 only. P3 will be allocated for 1 unit of time, will complete by 4. Guys, as it completes 2 times, it has to left with 6 units of time. By the completion of 4 units, it is able to add with one more process P4, right? So when P4 is added, which one having the highest priority again? Which means out of P1, P2, P3, P4, which having the highest precedence? Again P3 only. Again scheduled for P3 and will execute for 1 unit of time. Good. By the completion of 5 units, again one more process arrived, P5, which means now the priorities are 8, 9, 10, 7 and 12. Which one having highest precedence now? Now highest precedence will be given to the number 12, which means process P5 having the highest precedence. So P5 will be allocated for you. Guys, P3 completed 3 times here, it should be left with one more unit, that is 5. P5 got the chance and allocated for 1 unit of time, decreased by 1, 6 and it will complete by 6. By the completion of 6 units, P6 also added to the ready queue, but the priority will be given to only P5. P5 will be added, will be executed for 1 unit of time, complete by 7. Good, which means it will reduce by 1 more time. And by the completion of 7 units, what are the processors available? P1, P2, P3, P4, P5, P6. Out of that, which processor has the highest precedence? P5. So P5 will be given again one more chance. P5, 1 unit of time, 8, decreased by 1, that is 4. So by the completion of 8 units, P7 also added. But precedence will be given to whom? Given to P5 only, because it's having the highest precedence. So again P5 got the chance, will execute it for 1 more unit, 9. As all the processors are readily available, the processor which has the highest precedence, right? So which means it's having P5 only, right? So now P5 is allocated for how many times, guys? 1, 2, 3, 4. 4 times allocated, which means it has decreased 1 more time. Now as P5 is the highest precedence process, I can simply add it directly. P5 left with 3 units, that means 12. P5 complete by 12. Next, given chance to which one? Given chance to this one, P7, and will complete for 5 units, done by 17. Next preference will be given to P3, completed for 5 units, done by 22. Next, given chance to two process, P2 and P6. Which will get the chance? The process which having the first arrival time, that will be given chance, because when priorities are same, you can go with the arrival times. So P2 get the chance, allocated for 3 units. So P2 is done. So which will be done by 25. Next, P6 got the chance, will be executed for 6 units of time, done by 31. Next, P4 will get the chance, will execute for 3 units of time, done by 34. Then guys, here you have to check, not P4, given chance to P1 will execute for 4 intervals, that will be 35. Then next highest priority will be P4, will execute for 3 intervals, that will be done by 38. Right? I think all processes are done. So this is the Gantt chart for the given data set with the priority scheduling algorithm. So the scheduling length here L will be 38 minus 0, which will be 38. Right? So this way priority scheduling algorithm with the preemptive mode is going to work for you. Hope you understood this video clearly. Thank you.